Hello everyone, welcome to my YouTube channel Physics at Baharampur. Here we will discuss about the solution of second order homogeneous differential equation. So the second order homogeneous differential equation will look like this. Okay, here y is function of x and y is known as the solution of the differential equation. We often call it as complementary function. Okay. Now to solve this kind of equation, we have to consider the y, that is function of x, as a trial solution. Okay, so let's consider a trial solution, that is y equals to a e to the power mx, where a and m are unknown constants. Okay, so if you take the derivative of this trial solution, that is dy dx, then you can get dy dx as my and d2y dx2, that is the further derivative of the trial solution, you will get d2y dx2 that as m square y. If you put all these values, then the second order homogeneous differential equation will look like this. Okay, in places you just put those values. Okay, and by considering and taking the y out of the bracket, you will get the equation like this. So obviously y is the solution of this differential equation, that is y cannot be 0, so the bracketed term is 0 and this equation is called auxiliary equation. It is the quadratic equation of m. So you will get m have two roots. Okay, so if we take different cases, that is the different values of m, we will get different solutions. So if in case of 1, m1 and m2 are real and different, and we will get complementary function as this. In case 2, m1 and m2 are real and equal. In that case, complementary function will look like a1 plus a2x into e to the power mx, and we have taken m1 and m2 equals to m. Okay, so these are the two cases. And lastly, if we take case 3, then in that case m1 and m2 are different and both are complex. So if we take m1 as alpha plus iota beta and m2 as alpha minus iota beta, where alpha is the real and beta is the imaginary value, then complementary function will look like this, that is e to the power alpha x into c1 cos beta x plus c2 sin beta x, where c1 and c2 again unknown constants. We can calculate those values or evaluate those values by using proper conditions given in the question. Okay, so this is the process to calculate the complementary function of second order homogeneous differential equation. I hope you understood all those processes. Further we will take the examples and we will learn how to calculate those equations properly. I hope you all understood this. Thank you.